Okay, in this lecture we've started to look at our ideas, or continue to look at our ideas of understanding the atom and what the structure of the atom is. We started from J.J. Thomson's plum pudding model of the atom, where the electrons sit floating in a sea of positive charge. We then went on and looked at Rutherford, the experiments Rutherford did, notably where he scattered alpha particles off gold, and when that happened he showed that the atom was mostly empty space but with a very dense nucleus where most of the mass of the atom is held. He theorised, or it was theorised, that the nucleus had got these positively charged particles to counterbalance the electrons going around the outside. However, when the measurements were made of the charge to mass ratio, it was found that these were still wrong. Okay, until it eventually, in the 1930s, Chadwick demonstrated this other nuclear particle called the neutron, which of course is pretty hard to detect because it's neutral. So lots of our kind of existing techniques for detecting things rely on sensing charge, but because there's no charge on the neutron, it made a particularly hard particle to demonstrate. So from there we went on and carried on looking at nuclear material. So for instance, we've gone through and shown that the density of nuclear material is incredibly high. Okay, it's some of the densest stuff in the universe. We also then went on and moved on and looked at how we write atomic notation down. And it's very important that you remember where we've got this formalism where we have A, Z, E, where E is the particular element we're talking about. A gives us the number of neutrons plus protons. Z gives us the number of protons, and it's the number of protons that uniquely defines an element's place in the periodic table. Okay, so as Z changes, so we move from one element to another, but the number of neutrons can vary. Okay, so when the number of neutrons varies, we have an isotope. So the example that we looked at was the isotopes of hydrogen. Okay, so straightforward hydrogen just has one proton. We can have deuterium, which has one proton and one neutron, which is an isotope of hydrogen, remember, because we've still only got the one proton there. We can have tritium, where we've got two neutrons and one proton, but it's still an isotope of hydrogen. So we looked at all of those kinds of things. We had a brief look at nuclear stability before moving on. Next time we're going to talk about some ideas about radioactivity and what happens when atoms become unstable.